welcome to TecQuipment's webinar on environmental control and solar. And this is a practical teaching overview that we're bringing to you today on YouTube. Over the course of this webinar, we'll learn a bit more about TecQuipment. If you don't know who we are and you've just stumbled across this session, you'll learn more about how we deliver practical teaching equipment specifically for understanding environmental control and solar. We'll be talking about remote learning. We'll look at the other ranges of practical teaching equipment that TecQuipment provide and some other bits and bobs along the way. This is live. You can put your questions in the chat box. If you're watching it on demand, do feel free to put your questions in the comment box and we will come back to you with those. Do let us know who's out there listening. I know you are, so put your names in the chat box now. Company overview. Who are we? Right, well, we're an organisation. We're based in the UK. We design and manufacture everything all under this one roof. And we have about 80 different sales partners that we work with around the world that sell our products on our behalf. We also sell it direct in the UK. As part of the products that we deliver, it's about practical teaching equipment. We're talking flumes, we're talking wind tunnels, we're talking engines, all of that kind of stuff that we'll talk about in more detail today. 450 plus products in our product range. It's a worldwide presence. We might be based in the UK, but we're very much an international operating organisation. We've got customers in more than 100 countries, within more than 1,200 organisations. If you check out our website, you can look at case studies that tell you more about those organisations that we work with. If you want to find out more about our history, we're 63 years old now, and it was a chance encounter by an academic and a clockmaker where it all began. Less about that, bit more about us as principles as an organisation. We're about creating the best products for practical teaching of engineering principles. Now that's just marketing blurb to many of you, but what it really means is we're trying to create real life understandings that improve employability by having real kit that students can get hands on. As well as that, it's about, as an organisation, we've got connections with all these different organisations, institutions around the world. So we try and deliver as much opportunity for the community as a result of that by providing social communities groups. If you're not familiar with the practical teaching and engineering education community groups on LinkedIn and Facebook, I would encourage you to go and check them out. We also work very hard to help academics in motivating and bringing connection to the real world of engineering through student competitions. We had a prime example of that with Nottingham Trent University this week, where we announced the winner of their 2020 student competition. Now, principles of product design. It's all about really fostering curiosity and sparking passion. That's what this is this is what we do. But as a sideline to that, we believe in things that products that stand the test of time. They want to last decade upon decade. We provide a 5-year warranty as standard. But at the same time, as we're designing those products and we're making future improvements, we're thinking about how can we make products work better in terms of being faster, being able to perform experiments faster, but not remove those learning outcomes. So we will still want effective experimentation. Obviously, that's going to be a balance. To simplify teaching, we're constantly looking at changing syllabus and how we can integrate functionality to reflect that, and to make things easy so that academics can just pick up and run with pieces of equipment. We provide supporting instructional and theoretical material in the whole manual that we provide. So it's very much a whole rounded package ready to go. Now, that's not really what you want to hear about today. You want to learn more about environmental control and solar and the practical teaching of this. And this is the point that I hand over to Dave for you to tell us more, Dave.
Okay. So environmental control. Thanks for the intro, Dion. And you're still using my favourite word, which is holistically. I absolutely adore that word. Do not stop using it, even though I don't know what it means yet. But anyway, what are you here for today? Well, we're going to look at environmental control. But before we even start looking at the products, I always start these webinars with sort of definitions, like last week, thermo or thermachines. What is environmental control? Well, my definition of EC for short, it's the heating and the cooling of an environment that impacts the temperature and humidity of a space, of a physical space. So that could be a car, could be an aircon, could be a fridge, it could be a walk-in refrigerator, it could be a building with a HVAC system, and it could be your home or a hotel room. So that's my definition of environmental control. So we just move on to the next slide there, Dion.
Okay, let's look at practical teaching now.
Right, so, well, our range of environmental control teaching equipment covers all the fundamentals and the theories associated with thermodynamics, fluids, heat transfer, and that allows the student to understand the environmental control in the industrial world, but also in the consumer world, so like your fridge at home, for example. So our range, or EC, it kind of falls into 4 categories that you can see there. We have cooling, refrigeration, air conditioning, and humidity, and we'll talk about the solar equipment later. So if we look at cooling first, Dion.
Okay, so cooling tower.
Yeah, well, I'll give some talk on each of these slides, then you can play the videos if you want, after I've done my little bit of patter. So EC1000, this is TecQuipment's cooling tower apparatus. It's a benchtop piece of kit, demonstrates the characteristics of an evaporative cooling tower. It has inbuilt VDAS, so that's what the V means at the end of the title, and that will give live displays of air temperature, relative humidity, and it uses a psychometric chart. Now, before I get carried away, I'll talk to you about a psychometric chart later, but basically this measures the evaporated water loss, and it gives you a complete understanding of the cooling process. So tell me if I'm wrong, I think we have 3 interchangeable columns, each with different packing materials and densities.
I think we have 4, Dave.
Yeah. And I think
one comes as standard, and then you can buy an extra 3. Yeah.
So these optional columns, you can also have a column with no packing whatsoever. So that would be what's known as free-for cooling. Okay. Now all of these columns have they're clear size, so you get a nice clear view of the heat transfer process. Okay. We can vary the water flow, we can vary the air flow, so we can maximize those heat transfer experiments. And the cooling tower does come with 1 tower as standard, and then you have the choice of 3 more different packing densities columns. Tell me if I'm wrong though, Dion. I'm going from memory here, but
I believe that is correct, Dave. Now, I want to just clarify one thing. Some people think of cooling towers in terms of a power station, and that's what they see this as, in that limited scope. But it's so much more than that, isn't it?
Yeah, I mean, you would see these in industry, in oil refineries. I mean, but the obvious one that springs to mind is what you just mentioned. It has to be, power stations. Yeah, but I personally, I've not come across these in industry because, in my capacity, I just mainly go into teaching establishments rather than in the industrial world, Dion.
Right, great. How easy is it to swap out these different towers?
Wow, I mean, very easy. They are secured to the base or the platform by 4 quick release knurled screws, and then you'll have to quickly disconnect any thermocouples and any water connections, but these are self-sealing like the TD360 and the 1002. Very, very quick. We encourage the students to do this. This is their job, and we encourage them to get off the phones and get their hands dirty, or possibly wet in this case.
So you could, if you had 3-hour lab session, you'd be looking at covering all of these different ones potentially in that lab session?
I would think so. I mean, I'll be honest, I've never done all 3 in the manner that you explain, but because of the quick heating up and the cooling down, you know, once that reservoir water is up to temperature, the swap out and the continuity is quite quick.
Right, brilliant. Do you want me to play the video now? Or have you got more to say?
Yeah, it's your choice. It's your choice, Dion, if you want to have a whirl with that.
Let's see. We'll just skip to a bit where it's actually operating. No, it doesn't want to play ball. Let's get it. No, we will get it to behave. Don't worry, Dave. I just need to persevere.
Well, don't worry.
I'm going to let me do that.
These videos are available on our website anyway, so.
Yes, so they're all on we've got a videos page on our website. We've also obviously got all the different playlists. We've got an environmental control playlist, and this video is in there. So look, you've got a nice close-up of inside the tower there. We should have some
There may be more than just 4 securing screws. There may be 6 actually, so.
Right, brilliant.
Okay.
So I'm giving you a little preview of what's coming up now. Just everybody gets a list. I'm teasing everybody. Everybody.
So refrigeration next, I believe.
There we go. Refrigeration is here. There you go.
Okay.
I just want to keep everybody on track, knowing what's coming up, so they stay watching with us.
Yeah. So just I should point out that because I've been installing all these ranges for many years now, the refrigeration or the EC range is probably the newest for my skill set. So I've not actually ever installed any EC, but I have demonstrated this EC 1500. So I'm going to go into a little more detail now about a bit like a product focus, if you like, just to go into why we do it and a little bit more of the theory. So what is refrigeration? Well, it's really defined as cooling a substance to a temperature that is lower than the general environment. Okay, that might sound a bit strange, but basically we do that by moving the heat from one place, so that's a heat source, to another place, and that's a heat sink. Okay, so the EC 1500 then is a benchtop apparatus. It allows students to investigate and observe the stages of refrigeration. Now, what's that? We can look at the coefficient of performance, superheat and subcooling. The students and the lecturers will talk about how to use and understand a pressure enthalpy chart, and we'll come onto that slide after I've spoken now. Like I said, we look at superheat and subcooling, a basic refrigeration cycle, energy balance, and the coefficient of performance. Okay, so the EC 1500 has some major components. We have a compressor. Okay, we have a helicoil condenser. We have a thermostatic expansion valve, or a TE valve for short, and then we have a helicoil evaporator. Now, the apparatus, the EC 1500, comes with refrigerant known as R134A, and that's a really good picture there. If we can just freeze that, Dion. So R134A is known as tetrafluoroethane. I think that's quite a tongue twister. Tetrafluoroethane. Maybe that's the basic principle of it. Anyway, this is a refrigerant that is non-flammable, non-corrosive. It's low toxic and has good thermal stability. And this is a commonly used refrigerant used in automotive, air conditioning, and commercial refrigeration systems. So I mentioned before a pressure enthalpy chart. Now, hopefully there's a slide coming up of a pressure enthalpy chart, and we include there we go, perfect, thanks Dion. We include a laminated chart with each of our equipments, as well as a clear chart in the manual. So, okay, pressure enthalpy. Well, we know what pressure is, that's easy to define, but what is enthalpy? We've all heard of enthalpy in the sales environment at work. We all go through the manuals, the catalogs, we read it, but what is it? Now, our engineering team at TQ will know what enthalpy is. But basically, it's heat content. Heat content is also known as enthalpy, okay? It's a measure of how much a heat or gas or liquid can hold and how much heat is needed to change the temperature, okay? Now that's an awful lot to take in. So I'll just repeat it. It's a measure of how much heat a gas or liquid can hold and how much heat is needed to change its temperature. So that's enthalpy.
So obviously, I guess, Gabe, if you're looking at a water over an oil,
yeah,
that's where you would see that you need lower temperatures to heat up
it's how much
oil. So the enthalpy would be lower. Is that correct?
Well, that's open for discussion, Dion.
Oh, okay. Sure. Right. I'm a complicating matters here.
Well, I just know from my previous life at another company, that's my definition. It's how much heat is needed to change the temperature of another heat source. Okay, so it's quite a tongue twister. Now, in a refrigeration system, regardless of the type of refrigerant that's being used, the refrigerant is present in two different states in our EC 1500V. Okay, it's either present as a liquid or as a vapor, or in other words, gas in brackets. So liquid or vapor. Now, during the refrigeration cycle, it changes from one state to another. Okay, that's what it's all about. That's what we want to look at. So the students need to be familiar with the properties of both the liquid and the vapor in order to understand the cycle. Okay, now in our manual in a VDAS, which is on board, there are 5 properties of vapor. Okay, we have T for temperature. Well, we know what temperature is. It's the hotness or the coldness of a body. Okay, H is for enthalpy, heat content, which we've already mentioned. V is the volume. Okay, so that's not too difficult. It's the volume is the measure of the space that is occupied by, in this case, the refrigerant or the vapor. S stands for entropy. Now, entropy is different to enthalpy. Entropy is a bit harder to understand or harder to define. Okay, entropy is a ratio of the heat content of a gas to its absolute temperature. So it's a ratio. Okay, when the entropy is constant, okay, the condition of the gas is called isentropic. Now, all these key words you'll find on our data sheets and in our manuals, but these are the definitions, okay? And then finally, we have pressure. Now, we know what pressure is, so I'm not going to insult the audience by explaining what pressure is. Now, these properties, Dion, they are key to understanding and using the pressure enthalpy diagrams. And such diagrams, these diagrams, basically, they chart the properties of the gas. Okay. Now, this slide that we see here, this is the most common type of pressure enthalpy charts. Okay. This chart, it shows all 5 properties, like I mentioned before. Pressure on, let's talk about the axes. Pressure is listed on the right-hand side and the left-hand side. Okay. The horizontal lines that you see are the constant gas lines. Enthalpy is shown or listed along the bottom and the top of the diagram, and temperature, entropy, and volume are shown on the curves. Okay, so that's what this diagram is all about. Now, the great thing about the EC 1500V is it actually plots a live display of the cycle as it's processing. So we have a process. We actually have 4 or 5 processes, and VDAS will actually plot the points on this diagram. So between points 1 and 2, we have compression. Points 2 and 3, we have condensation. Points 3 and 4, we then have expansion. And then from points 4 back to 1, we then have evaporation. So VDAS would actually build a horizontal point, a bit like a horizontal image of a phone. You'll have 4 points on that VDAS screen, and from there we can save that the chart. You can print it and you can export it. So this is absolutely key to understanding refrigeration. That was a lot to take in there, but that's basically what a pressure enthalpy chart allows you to understand. Yeah, that's a long paragraph there, Dion.
Okay, I've got a question for you, Dave. How does the VDAS output compare to this pressure enthalpy chart here?
Well, at the moment,
do they look very similar? Or?
Yeah, well, at the moment, this is not showing anything because nothing is actually being plotted.
Okay.
If you could pull up the manual for later on in the show, I would love to.
Okay, I'll see what I can do.
Maybe not now, but I would love to be able to show a screenshot of what that looks like when we've actually plotted the refrigeration cycle. So we'll see 4 points connected by straight lines, and those processes that I've just mentioned would make a lot more sense to talk about if I could see a screenshot in the manual. But we can come to this later, okay?
I have a manual, Dave. Are we talking EC 1500 or EC 1501?
It's the 1500V. V is important because the VDAS is built in, and maybe in the results section, you'll be able to scroll to the manual.
Okay, well, I'll let you carry on, and
okay.
Or I can show it you now if you want.
Well, you know, I'm in no rush. I hope the audience has time.
Okay, here we go. Let me show you now. It looks like I do have it. Here it is.
If you can do that, Dion, that
working on the fly, is there? Let me show you this now.
Yeah, there's a bit of lag here, so.
Right. Okay. I'll just reduce the size of this so we can see it.
This is actually quite exciting. Okay.
Wow. Rotation. You're going to have to tilt your head to the screen, to the side, Dave, to be able to see this properly.
Now, you can see I'm getting a bit excited about this now. So you can see number one on the bottom right-hand corner. This is the compression stage of the cycle. Then we have that's between 1 and 2. Then 2 and 3, which is in fact that's the top right to top left. That's the condensation stage. Okay. Now then we get from 3 to 4. That's when the process goes through its expansion. So this super cool refrigerant liquid is then expanded through a TEV or thermal expansion valve. The pressure reduces, and as a result, in a decrease in the temperature. This kind of forms a mixture of cold vapor liquid, and that then moves to state number 4. And then finally, from number 4 back to number 1, which is completing the whole cycle. This super cold vapor liquid moves to the evaporator. It absorbs heat from the air or in the duct, and it causes the refrigerant to vaporize. This results in the air being cooled. Key word, we've now cooled some air. Bingo. Okay.
Brilliant.
And then the cycle starts again. And it's over and over again. But this rectangle actually builds. Once you switch on the EC1500, you switch the compressor on, and the water supply, you can then view this cycle growing into the shape that you can see there. So yeah, thanks for putting that up, Dion. That's a great thing to show.
No problems. Okay.
So
are you ready to talk about air conditioning now?
Of course I am. I'm on a roll.
Whoa.
Yeah. So air conditioning. Now, what you can see on the right-hand side is our EC 1501. Okay. Now the V at the end, again, you may have heard this before, but the V stands for VDAS, onboard VDAS, built in. It's plug and play. Within 3 clicks, we're getting data actually being produced. So that's a fantastic resource. The EC 1501 is a benchtop apparatus. It allows students to investigate the fundamental principles of air conditioning. Okay, it allows us to investigate this at a basic level, and we can use pressure, enthalpy charts. Now you know about those now, but also psychometric charts for their calculations. And we'll talk about psychometric charts in the next slide. And then we can discover the enthalpy change. So with the 1501, we can determine enthalpy change in the airflow. We can learn how to use the charts, and we look at superheat and subcooling. So if we can move on to the psychometric chart there, but there's a nice video playing there of the 1501. And like we're both saying, all these videos are available on our website to view and get a better understanding. Okay, so what's a psychometric chart? Okay, it's a graph of the thermodynamic parameters of moist air, so humid air at a constant temperature. Okay, that's quite a lot to take in.
Okay. Yeah. Right. Okay.
So we are looking at a dry bulb, dew point, and a wet bulb. So we are, in fact, we're determining from this graph, we are actually determining relative humidity. Okay.
Okay.
So on our equipment, so example, I won't jump too far ahead, but on the TE6 that's coming up, we actually have many methods for calculating relative humidity. And in fact, we actually include it on some of our equipment without us knowing. On the GT103 two-stage compressor, we actually have a wet and dry bulb sensor on the inlet of the air, as the air comes in on the left-hand side. We actually have a wet and dry bulb because we need to know how humid the air is. Now, without going into too much detail, a wet bulb is basically a little container of water with a wick. Okay, that wick is immersed in water, and we measure the temperature, and we make a note of that temperature. Now, dry bulb, well, it's just atmosphere. So there we have two temperatures, and we want to take these two temperatures, and we use this graph to find where the wet bulb meets the dry bulb. Where those 2 points meet, we have a relative humidity of moisture in the air in percentage. So it's a very basic calculation, and that's all this this chart is doing. So basically, like I said, this psychometric chart, you are using your known temperatures to determine the relative humidity. Okay. So now then.
Good. Well, I do want to see the manual of this one as well, with the results on it.
No, there's not actually, there's not actually anything displayed on this. It's just a case of the students taking his two temperatures and using those coordinates to cross. And where they cross, we find a relative humidity. Okay.
Right. Talking of humidity.
Well, that really brings us on. That brings us on nicely. I mean, look, this is basically a wind tunnel. Okay, it's a wind tunnel,
right?
But we are showing the principles of humidity measurement, and we are comparing it with different methods because there are different methods of measuring humidity. Okay, inside the TE6, we have it's like I said, it's a wind tunnel, so we have an airflow duct. So we measure the volume of air in a duct. We are measuring relative humidity using different types of instrumentation, okay? And then we are comparing those measurement methods for accuracy and ease of use. Now, can you see on that picture, there's a strange device that's got a handle. That's it. That's a wet and dry bulb. On the right-hand side, there's a wet bulb. That will be filled with water, okay? And the little bulb on the right, well, that's not got filled with water. So when you spin it around, you remember the old football rattles in the 1960s and 50s? Yeah, can you remember
Well, I
this?
don't remember the ones from the 1950s and 60s, but I remember the one from the 80s and the 90s.
Okay, 80s. Well, look, once you've got those bulbs primed, you walk to the outlet of that T6 where the air is blowing out, and you whirl it. You spin it around like crazy for about, maybe about 20 or 30 seconds, okay? You then walk to the front and you measure the temperatures, and you'll have 2 different temperatures. You'll then go to your psychrometric chart, and you'll use the coordinates to meet, to intersect, and then you'll go and you actually note down the relative humidity, okay? And there's also a electronic device inside the duct that's measuring humidity. And then we have, now get this, I don't know if any of the viewers are into horses. I'm not sure. I'm sure they'll tell me. But we have a horsehair hygrometer. Can you believe this?
Oh,
we
astonishing.
We take the thinnest strand of horsehair, okay, and that's used in a hygrometer because the horsehair absorbs water, and an extremely sensitive meter actually measures the change in the characteristics of the horsehair. Okay.
Wow.
Trust me, you have to believe me. There is a horsehair hygrometer in that TE6. I'm not going crazy, Dion. I know there is.
I'm going to have to look into this when we've got one in the factory.
I'm willing to place bets on anybody that we use a horsehair hygrometer, and you then do the experiment and you look at the different methods. So, yeah, there we go. And that's the TE6. Lots of different methods for measuring relative humidity and, well, humidity measurement, okay? I'm taking a break. I'm taking a break now.
Yes, okay. So now we're going to move on to solar. It's anything like the weather I have at my home here right now. I don't think solar would be operating particularly well.
No, well, I mean, we had the driest, warmest May on record, and I think we're on target for the wettest and coldest June. It feels like it, you know? It's crazy. So, okay, so solar energy. What does TecQuipment have to do with solar equipment? Well, this range, it offers teaching equipment for the core principles of energy, solar energy, and that will include PV cells or photovoltaic cells. We have a flat plate solar thermal energy collector, which is what you see on the right hand side, okay? And we have focusing solar energy collectors. Now, students on all of these equipments, they can learn about the efficiencies and, well, the limitations of each of the methods, okay? So if we just focus, excuse the joke, if we can focus on the if we can focus on the
boom, you can't help yourself, can you, Dave?
I'm just a ray of sunshine today.
Oh, wow. Keep it up.
No, I can't.
The VDAS screen. We're lacking focus on the VDAS screenshot, I'm afraid.
I know.
It reflects the kind of weather that we've got today.
I know. I'm just I'm all these jokes you can't keep up with my solar jokes.
Look, Dave, can you just focus on the topic in hand here, please?
Okay, I have nothing to say. TE38, what's it all about? Well, it shows how a focusing solar energy collector works, and it allows students to study its performance, okay? So we can demonstrate its performance. We look at the advantages and the limitations, and we can basically measure the efficiency of that collector, all right? And then the next piece of equipment is the T39, I think, on the right-hand side. This is anything but a tabletop piece of equipment, okay? This is like a 6 foot tall collector, and it illustrates the workings of a flat plate solar thermal energy collector, okay? And it allows the students to study the performance of the collector. We look at the efficiency of the collector. We look at the heat losses associated with the collector, but we can also actually look at the effect of altering the angle of that collector. You can see it's a bit like it's on a stand at the moment. So like those rear pins or bars can be adjusted to change the angle. And we have a solarimeter, which is measuring the solar radiation. And the units are, I think it's WM squared, I think, going from memory. So we can optimize and look for the best angle of that collector. Now, we do give sample angles in the manual, because depending on where you are in the world will affect what angle you need to set to. Now, I've installed these in some very, very hot countries. So the most fierce environment was in Saudi Arabia in the summer. Now, I don't know if Adnan is watching, but Adnan will know what it's like in the summer in Saudi Arabia. We're talking temperatures up to 50 degrees Celsius. So it didn't take long for the thermal cutout switch to work. Equally, I've installed these in Guyana, in Greece, in Dominican Republic, and also the country escapes me now, but near Indonesia, I think. Indonesia. So yeah, a very useful piece of equipment. Next.
Right, next up we have...
Oh, we've just seen that, so I think we're looking at...
Yeah, there we go. Photovoltaic cells.
Oh, this is one of my
Just catching up. There you go.
Yeah, of all our solar equipment, this is actually my favorite. So we are using PV cells or photovoltaic cells to help the students look at the performance of these cells and to capture solar energy. We're using solar energy to basically generate electricity. Okay, we can look at the performance of and the use of PV cells to capture the energy. We demonstrate the performance and a cell array and a battery storage system. So it includes again a solarimeter for the optimal angle of the collector. We have a charge controller, and we have a control module that measures shows the displays and the DC outputs. So we are taking solar energy, we are generating DC energy, okay, which we store in batteries. Then we have an inverter, and we are actually converting DC to AC. All right. So
right,
the collector will be outdoors, obviously, and then these control boxes are indoors. We are taking literally the power from the sun. We have DC power, DC electricity. We are then converting it to AC, and we have an output. We can actually plug a cable in, and we can fire up light bulbs. So we are creating free electricity apart from the power to power up the control unit. So from memory, I've actually powered some 60-watt bulbs in a hot country, which is very, very interesting to show. But of course, we can't do this at night because we can't store AC. All right, we can only store DC. I think I'm right there. I'm pretty sure I'm right. So that's what the T4 does. And of course, with VDAS, we can look at the performance, the efficiencies, the inputs, the outputs, the battery voltage. We can look at float switches, float modes, and all sorts of parameters. But that's my favorite piece of solar equipment because it's so real life. Yeah.
Brilliant. Thank you, Dave. I think that pretty much brings us to the end of the overview of practical teaching equipment.
Splendid.
Now, we would talk briefly about, you've mentioned lots of countries that you've been to that is installed pieces of these practical teaching equipment. You referenced particularly on the solar side of things.
Yeah.
We've got a few video case studies that people might want to look at. Ben, get ready. We're about to show Ben's video case study here. I'm going to put it on mute. At Nottingham Trent University, they've got a wide range of teaching apparatus from TecQuipment. Right in the background there, behind Ben, what you can see right there.
Wow, yeah. Well, look at that. Look, that looks like an EC 1500V, I believe.
Yes, that's right. So in their labs, they've got a range of different pieces of apparatus to make a very comprehensive practical teaching environment there. I'm just skipping through it very quickly.
There's a wind tunnel there, subsonic wind tunnel.
Wind tunnel. Yeah, engineering science kits.
Wow, yeah, fantastic range.
Yeah, and what else have we got there? I think that's it. I've skipped through that exceptionally quickly because, of course, you can watch that at your own leisure on the TecQuipment YouTube channel or on the website. Yeah. In a similar vein, Birmingham City University, we were there with Carl Snape last year. They've got a very comprehensive lab, again, using a combination of engineering sciences, fluid, aero, theory of machines. I'm going to see if I can just find an image, part of it that actually shows some of the environmental control kit.
Yeah, so we have a temperature measurement bench, ES panels, wind tunnel. They have a flume in the basement there as well. This
is a pretty good lab here. You can see.
That is
about
good.
To pan over to the left there.
Yeah, that's a good
a couple
span.
of students working on those.
Span and pan. Yeah. Yeah.
So if anybody's looking for what a lab layout might look like, pieces of kit they might use for a kind of comprehensive lab, I would suggest you have a look at both the Birmingham City University video case studies and the Nottingham Trent University video case studies.
Yeah, these are close to TecQuipment as well. So we've got vibrations there. We've got TM164.
And this is what we have coming up next week. We have our topic for next week will be engines, and there is the engine test bed. Yeah. So we'll be coming back to that shortly. So that's us for case studies. Dave, you can sit back, have a biscuit, get yourself another can of Coke while I talk about remote learning.
Diet Coke break for David.
Very good. So I'm going to talk about remote learning now. This is a challenge that many people are encountering at the moment. What on earth do you do in the current climate? And TecQuipment, we've been very conscious of seeing how that landscape is changing, and it is changing daily. We're looking ahead to how we can best support you. There's a few things that we've had in place for a while that you can utilize. That is the communities that we have on LinkedIn and on Facebook for academics. They're the practical teaching and engineering education communities. These are designed so that you can share ideas. I think people are a little bit shy about asking and sharing ideas. I'd encourage you to just go in there, be bold, share those ideas, ask your questions, share your challenges, and see if together you can collaborate. We've also got on YouTube, we have a community now that is open for everybody. So the practical teaching and engineering education communities, they are not for students. That's very much of an academic environment so that you can feel free to talk about the education challenges in a more kind of closed, safer environment. The one on YouTube is for all and sundry, everybody to get involved in. So students could utilize that as well, share ideas. It's got the option to poll, all that kind of thing, which you can do yourself and get involved in. There's various resources that we've got on the remote-learning-support area of the TecQuipment website. We've got an engineering videos guide, a PDF document with reference to lots of different videos in there, student user videos, general industry videos. It might be understanding what a culvert is, for example, not from TecQuipment, just general interesting real life content that you can interweave into your digital learning content. Student experiment videos. Ben, if you're still there watching us, we've got many of the student experiment videos are courtesy of his students at Nottingham Trent University who participated in the TecQuipment 2019 and 2020 student competitions. Some fantastic videos in there of students. For example, you can see one here of Francis Turbine using a wind tunnel, emissivity testing with different aerodynamic properties of spoiler designs. Lots of great content that's really engaging to students if you can't get them in the labs. Now, some of you will be thinking, you will be opening your labs. You may be thinking about how can you run lab sessions in a socially distanced perspective. We are looking at how we can best support you that way. Some of you are looking at how you can do lab videos yourself. Maybe you're doing live streams, or maybe you want pre-recorded content. Yesterday, in the live Q&A session, I had a video editor and post-production specialist on the line with us, and we were talking about different considerations. Things like, his opinion is, if you've got a really good, semi-decent smartphone, you can do pretty good results. You can get close-ups, you can live stream with that, you can do pre-recorded content. He provided some general tips on there. We talked about video editing, and that can be your massive time sink. It's a big learning curve. I know it from my own experience, the learning curve that I've had to undertake. But YouTube's amazing for tips on that. I would recommend you have a look at YouTube. I did a very little short video that takes you through a few tips for consideration when you're creating lab experiment videos. Really simple stuff like adding close-ups, adding cutaways, thinking about your lighting, thinking about your background. Our guest yesterday highlighted that if you've got a room with a window, that's really, really advantageous. It really picks up the lighting. Lighting makes a massive, massive difference to the quality of your video. This video, this little short snip that we've got here, this is available for you to watch on the TecQuipment YouTube channel, on the website, as with all of our videos. The last thing is we're delivering these webinars. That's something that mainly is for academics, not so much for students, but there's scope to do for stuff for students. If you really want to get us involved, then do get in contact. Dave and I, we've done sessions and for individual customers where it might be, I think you were looking at the GT100 recently in Lebanon, Dave. That was in April. I might have got the product name slightly wrong. Dave is mid-biscuit and doesn't want to unmute himself at this point. But we do have also, sorry Dave, you ready? You're back?
No biscuits, I'm all ears.
Yeah, I was just explaining about the session that we did for Lebanon. I think it was in April.
Oh yeah, that was really, really productive. Yeah, that was a fantastic session. That was a few weeks ago now.
Yeah, it was. So yeah. As well as doing those, Dave, we're always here on Wednesdays, aren't we, on YouTube, doing our live Q&A sessions.
Yeah.
Dave takes all the random questions that I can throw at him and that you can throw at him. And many a time, like this week, I give him no preparation in advance because I really want to make him sweat, feel the stress, see how good he really is.
I must admit, I have sweated today a little bit. But
You've done a really good job. So do join us for those live Q&A sessions. Now, they are open to students, to academics, anybody who sees that they want to get involved in understanding more about engineering education. That's what they're all about. We have guests on there. Last week we had Murat Islam, who works in kind of coupling design, and he was talking about how materials testing is used in his real life job. We learned more about his career and his challenges in education. He even talked about mental health and some of the challenges that he very openly discussed with everybody. So there's a bit of all sorts in these Q&As, and I would encourage you to join those if you have a time. It's 1 p.m. on Instagram on Wednesdays and 2 p.m. on YouTube on Wednesdays. Of course, that is British Standard Time I'm talking about. So do check your local time. All of these are available to watch on demand, much like these webinars are. So there's a whole bank of content that you can refer to now. Because we've got Q&As going back every week, back to March. We've got a whole bank of webinars as we're doing those weekly at the moment as well. That's just in time for me to take a breather. For you to talk, Dave, about ranges of all the other stuff that we do.
All the other stuff. Let's start with the well, what we might call the easy stuff, Dion. What about engineering science, where we have 18 modular experiments? The subject matters can include and do include friction, cams, moments, tensile testing. All these experiments sit on the panels, either in portrait, which you can see on the screen there, or in landscape. So depending on the method or the experiment, depends on the configuration of that panel. So a very good introduction to mechanical engineering. All the basics are covered in that range.
In there, I know last week Kyle referenced, yes, we've got 18 kits, so 18 of those individual trays, but within those there's multiple experiments. There's 66 experiments in total if you were to get the whole caboodle that you can see there. Yes.
You've taught me something today.
Yes, I'm doing gear trains at the moment. That's my current video. I'm writing the script on that, whether we've got belt chains and all sorts. So have a look at that for next week. That will be coming up. They are great. And what I like about these is that you can, just by doing a basic experiment without taking any readings, you can begin to get an appreciation. So if you're a school, you could have a go and get a general appreciation. But if you're first year mechanical engineering, for example, you can start taking measurements, working out different velocities and all kinds of things like that. I'm not very good at pulling off those terms, but there is extensive stuff and supporting material in the manual that gives you all the theory, all the equations that go with that. So you can just loads of lessons all in that one trolley there. Yeah.
You've probably had more exposure than I have to that, Dion, probably.
I think everybody in TecQuipment should be taking one of these or two of these kits home with them and having a play to get a full appreciation, because they are really, really cool. And only when you're actually hands-on, like the students, again, when you're hands-on, you get a total different appreciation for the topic.
Look, it's discovery-based learning, isn't it? That's what it is.
Yeah.
Okay, so fluids. Now we have an extensive range of high-quality fluid mechanics equipment for teaching in the laboratory. We, as a company, were the first company to offer a modular range of fluid mechanics and to look at the fundamental studies. There are practical experiments available for just about all fluid mechanics courses.
Brilliant. Right. Okay. Let's. That picture doesn't really truly represent it, but you need to check back at the fluid webinar to be able to really understand the whole range that we have there.
Now, do you know, because of what we're doing next week, I'm going to skip engines. Let's tease the audience. Let's get them back next week. I'm not even going to comment on this. Come back later.
Okay. Let's go to control engineering. Let's talk about SpaceX.
Oh, you like SpaceX,
this is the topic that,
don't you?
Yes, I like space. I like rockets.
Oh my goodness. Rocket man. Okay, so we are looking at control engineering principles, okay? From fundamental to advanced investigations into control engineering, using actual applications and the components found in industry, okay? So, for example, stability control of an aircraft or a ship even, and what about SpaceX as well? Another example where you'd find control engineering. All the CE range or control engineering, it includes our specialized control software. This is kind of free of charge software, and it can be used for data acquisition, but also for simulated control experiments. And that subject really brings us nicely into process control. Now, again, this demonstrates the fundamental and advanced studies in real life processes. So like temperature, level, flow, etc. We look at PIDs, cascade control, control of pressure, flow level and temperature, which I've just mentioned. Again, dedicated software, which we developed at TecQuipment. This supports our process control range.
We're going to flip right over to something quite different now to talk about electrical power systems. So,
I mean, wow, there's different and there's power systems. So this range offers, it provides advanced technical teaching and training equipment for all elements of a power station. Excuse me. That will be generation, transformation, transmission, distribution, utilization, and protection, all covered in the excuse me, the PSS1. So these scalable products, they give the students real hands-on learning of a power systems setup with optional hardware like a second generator and software additions like a SCADA system, so supervisory control and data acquisition. That's what SCADA stands for. So the PSS1 will give it all in one with possibly the second generator, or if it's budget dependent, we can go PSL 10, 20, 30, 40, 50. We can do the modular approach, and as more budget or need or application becomes available, so they can literally connect it onto their existing modules. And materials, I like materials because we break things, but this time we break things deliberately, Dion. Okay, we do it on purpose. We look at properties of materials, and this is so fundamental in engineering courses. Okay, it's a very comprehensive range. We look at tension, we look at compression, we look at impact, we look at hardness, we investigate stress, we look at strain, and we look at structural equipment and experiments. A lot of these experiments have local digital displays, but also the option of connecting to VDAS for taking data acquisition meetings. In some cases, the VDAS is essential because some of the tests may take, let's say, 100,000 revs per to snap a specimen. It could be 3 days before a specimen breaks. So that's where the VDAS is a massive bonus. Okay, thermodynamics. Well, this is small scale equipment or experiments looking at the laws of thermodynamics. There is real working systems, okay, with industrial components again, and assemblies. The thermodynamics range includes our GT range of gas turbines. For example, it uses real fuel, not bottled gas. Interlock, startup, and shutdown, etc. And the engine, has digital instrumentation. It can be connected to a computerified VDAS. So a whole range of equipment in thermo. And not finally, but structures. So 19 or so modular equipments where we can mount them into the standard frame. Okay, we have the option of data logging. We have the option also of simulation if you buy the STR 2000. So we're looking at shear, we're looking at bending, we're looking at stresses of a beam, redundant truss, 2-pin, 3-pin arches, portals, plastic bending, and so on and so on. So a very, very popular range of equipments there.
And this is some exciting news on this, because we have got a new range that we'll be releasing on this in the next generation structures range that we'll be releasing in September. So watch this space for news in September. For what we're offering there for increased usability, etc. I can't say anything more because I don't want to let the cat out the bag. Next topic, VDAS. You were talking about VDAS and you were talking about onboard and all the different options. Here you go.
Yeah, super powerful. Designed in-house by TecQuipment to work across multiple ranges that we're talking about now. The VDAS software itself is free of charge. It's downloadable, it's not protected, but of course you need the hub, or if it's a V equipment, you need the equipment. It's very easy to use, very intuitive, very easy to understand. And like I said, within 3 clicks, you've actually got data. You have data within 3 clicks. It's very easy to use. Some softwares I've used in the past, it's been frightening, but this is very, very easy to use and to understand and how to drive. It has many user-friendly features. You can have large displays, we have analog displays, we have digital displays. You can actually rename the displays in a local language if you like, which is not a lot of people know that until I tell them. You can change the colors. Very, very aesthetically pleasing, Dion.
And I like this because it is unlimited. The software itself, so you've got the hardware, you've got to buy the hardware in some cases. Some cases it's integrated on board, that's with the V on the end of the name of the product. But the software itself is free. So if you've got all of your students, your whole cohort, and they all want to download it onto their own laptop so that they can plug their laptops in to get the data direct themselves, they can do. They can go on the TecQuipment website and download it. It really is as simple as that. Not that they can't get the data anyway, because you can export it to Excel, so it's easily transferable. But still, if you've got a hardware limitation issue at university and students got their own laptops, and they can utilise those. The next one, Dave, is...
Yeah, just before we go on to the next one, we did have a customer care call inquiry this week, Dion, from Tri-Counties College. That is in the States and covered by LabCorp, with David Bulan being the local representative. The customer had a question: how do I capture data and export it? So using this platform of Zoom, I was able to share my screen, and immediately it became very apparent. He just had a problem with his local displays not showing full screen, so some of the dialog boxes were actually missing. So we just had to set the resolution on his screen, and abracadabra, everything appeared, and it was one happy customer. So that's always a nice achievement when you can help somebody like that, and that's what we're here for. Now I recognise that.
Well, that means, going on to that, before you get into one of your favourite topics, Dave, because I know you're really, really passionate about aerodynamics. Because Dave had this inquiry, we've decided that we will be doing a VDAS webinar in pretty much the same way that we've done this one today. It will probably be more actually how to use type of webinar rather than a practical teaching overview. So if you're wanting to know more about that, then do look out for that webinar coming up. I think we're going to do that in a couple of weeks' time.
We are, yeah. Well, you're keeping me busy,
there you go, Dave.
Yeah, you're keeping me busy.
Yeah, that's the way you're happiest.
Yeah, right then. Now I really do recognise this lab. Let me just give you a little bit of background. This is in a tornado shelter in Alabama. Okay.
Really?
Yes. In this lab stroke tornado shelter, we have 3 AF1300s, excuse me, which you can see lovely laid out there. But where this picture is taken from, if I was to look behind myself, we would have a intermittent supersonic wind tunnel. So wind is the subject here. If they're not escaping twisters or tornadoes, they're actually generating supersonic wind speeds in the basement. So a really exciting place to be, actually. And in the tornado season, this lab would be full up of either students working on equipment or students escaping what's going off at ground level. So quite an interesting environment. And just at the back of those wind tunnels, there are warning signs about what to do in the event of an evacuation and the protocol to follow. But yeah, this was one of my favorite installs ever because everything looks so good. So this is Auburn University. It's in the state of Alabama. So I flew to Georgia, somewhere in Georgia, Atlanta, and we drove to Auburn College here. The aerodynamics range is an outstanding selection of engineering, aerospace, and educational teaching equipment. It covers the whole subject areas of aerodynamics and airflow. We go from basic principles right up to research level on the larger wind tunnels, the 1450 and the 1600 cross section. These wind tunnels are cost effective. We have the modular low speed airflow bench, the AF10, where we have 8 to 9 different experiments covering Bernoulli's, boundary layers, lift and drag, flow around a duct, airflow, etc. Then we can move on to our subsonic wind tunnels, which I've already mentioned there. So the 1300s, the AF1125 benchtop, and then my favorite products in the whole catalogue would be the AF300 intermittent, which I've just mentioned before, and its big brother, the big daddy, the AF302 continuous supersonic wind tunnel. We also can look at flight demonstration wind tunnels. That's where students actually get to fly a model plane. So we're looking at lift, we're looking at separation, we are looking at stalling. We measure the wind speed in the knots, the force or the lift in newtons. We can see the flow separation because we put telltale tufts on the wing. So not only can you see the stalling on our displays, you can feel it through the throttle and the mechanism. And you can look at the altitude of the aircraft and the attitude. Now, attitude, Dion, is not when you get up in a bad mood and throw your webcam on the floor in a huff. Oh, no.
We definitely had a bit of that yesterday, didn't we?
Yes, we did, yeah. Attitude is the relation between the aircraft's nose in relation to the horizon. So that's what attitude is. It's not Dion Knowles throwing her hardware on the floor and storming off during the Instagram show. Okay.
That never happened, Dave. You're painting a very grim picture of me here.
The camera never lies. All right, so less of having a go at Dion. Theory machines. Yeah, this is what we've covered in the past. This is again, it's a kind of a favorite of mine. Just in that picture alone, we are looking at gears. We can look at vibrations. We can look at whirling of shafts, and also cams as well. There's a whole load of equipment just in machines that we can see in that car gearbox there. So, yeah.
Again, for the likes of fluid, thermo, theory of machines, we've got separate webinars available on those. Yeah. Do check out the links. Some of those links will appear at the end of this very webinar that you're watching today. So that's the end of the ranges. Well done, Dave.
Okay, no worries.
You can have a breather. I'm just reminding everybody that if you've got any questions, then do put them in the chat box, so that we can ask them to Dave at the very end of this session, which is coming up in just a couple of minutes now. I mentioned earlier, Dave's favourite word is holistic.
Oh, yes.
And
yes.
Something that we believe very strongly at TecQuipment is not just about selling products. Yes, providing really good manuals and great support, but we're also, how can we get more involved in supporting teaching, engaging activities, providing insight, bringing the communities together. I mentioned the student competition. If you want to get a flavour of how the student competition works, then do check out the TecQuipment Student 2020 competition video that we have on YouTube. If you want to have a look at some of the results, then have a look at the results from Nottingham Trent University. This was aired on Wednesday. You can see a preview of all 16 entrants, all the different groups there, where we announced a winner in that as well. We're also trying to shed light on trends and perceptions. We did a research report in 2019 where we looked at perceptions of engineering, practical teaching and engineering education. There's an executive summary available on our website. If you Google it as well, you'll probably find it very quickly. Interestingly, 90% of academics believe that practical learning is extremely important for student employability. Lots of interesting facts in there as well. just to give everybody an idea of where everyone else is around the world in terms of perceptions and perspectives. Now that brings me now to near the very end of this session. I would like to remind everybody, any questions today? My question first up, Dave, is solar. For example, what kind of engineering courses are going to be looking at solar? Are all the mechanical engineering courses going to be covering that, do you think? Or are there specific niches we're talking about from your personal experience?
Well, like I've been to various territories around the world that have different curriculums, different ideas, different nameplates on the door. So I've never walked into a solar energy lab. Okay. I have walked into mechanical engineering labs, but even that can be divided into workspace. I mean, in Guyana, there was a gas turbine at one end of the room, GT100 firing away, blowing out flame into the car park. At the other end, we had a solar collector in the sun. So I can't tell you exactly where we'd find solar energy because everywhere is different. It could be, I have seen renewable energies labs, okay, in the States for sure.
Yeah.
That would fall in nicely. That would slip in nicely into renewable energies. But, I would imagine our sales managers, our RSMs would have a better idea when they quote, because they always ask for end user details. I would think they would have a better handle of where they would sell into, if you know what I mean. I just walk into a corridor and go into the room. But I've never seen a solar lab, never.
All right, next question is, what's the favourite bit of equipment that you talked about today and why?
My favourite? My favourite?
Yeah, your favourite,
Well, I do like the, now is it the TE4 that I spoke about? Are you able to pull that up there?
I can pull it up. Let's go back. Let's dive through into, are you looking at? No, not that bit.
I'll put you on the spot now.
I'm playing catch up. All right.
Yeah.
I'll get there. Gee, what's it look like, Dave? Is it the humidity? No,
well, no,
actually,
I do the 1500 V is a favourite of mine. Now, I haven't installed one, but I have demonstrated one to Imperial College just before the lockdown. Now, of course, Imperial College is on the news for other reasons almost every day now, but that's a very high-profile customer, very famous establishment. And it is in my diary at some point to go and install a 1500, but I particularly enjoy driving this because it's so intuitive. It's so easy to follow with the color-coded pipes, the analog and digital displays. It is quite a pleasure to drive and operate this. I'm going to say that's my favorite. I've changed my mind.
That's your favorite.
This is my favorite. I'm so shallow, Dion. I mean,
it's just the pretty colours, isn't it, Dave? That's why you like this one.
Yeah, something like that. Yeah.
All right. Okay. Well, that's it from us for the questions, Dave. Thank you so much today. Thank you for everybody for watching us.
You're welcome.
As a quick reminder for those who are watching, if you're not already subscribed to the TecQuipment YouTube channel, we publish about at least a video a week. At the moment, it's more than that. So don't miss out on the content that we're putting out there to help both students, both academics, anybody generally involved in engineering education, inspiring people to get involved in STEM as well, whether you're at school too. Lots of material that you can access there. Don't forget, we're going to take us back here now, back to our homepage. Next week, we are talking engines. So we've got you, Dave, because this is one of your hot topics. I'd like to just get up on there. I hope you did. One of David's favourite topics. But we're also joined by the head of engineering from Trafford College in the United Kingdom, Oliver Shaw. Oliver will be talking about engines with us as well, which we're very much excited about. And Oliver will be joining us for the live Q&A next Wednesday as well. So we'll be covering some other topics there with him too. So we've got engines next week. Then we've also looking at doing a physics webinar as well, and we're looking at VDAS as well. So that's the next 3 weeks that you can look forward to on our webinars. So it's back with Dave next week.
Okay, fantastic.
Right, well, that's it from us. Thank you very much for watching, and we look forward to seeing you. Thank you, Dave. We look forward to seeing all the viewers again in the future. Thank you, and goodbye.
Thank you.